the Professor Mugwadi, he actually covered a lot of material too. That was really good. I really appreciate because I can shorten down my presentation a lot because this is all separation and nothing to do with the filtration. This is the busy slide, one of them. Solid look separation mechanism, sedimentation, we already talk about it, and centrifugation, flotation. Oops. Decanting is quite important one. The hydrocyclone, settling, thickener, magnetic separation, and electrostatic separation. So sedimentation, everybody who probably already know gravity-based settling, classifier. So advantage is cost, is low cost. However, it's kind of a little bit slow. And sludge dewatering. I believe you're going to have the copy of this one. So I'm not going to go detail, but decanting and hydrocyclone. Magnetic separation. I have some examples of magnetic separation. You look at it. The electrostatic, that's currently is quite popular area.
Can you raise the volume?
I think it's maximum. Did you know probably you don't know. I'm actually a singer. If I do it, I like to sing. I'm actually tenor. Huh?
When are you going to listen to your song?
Last day. At the party. But you have to do really good at exam too. There is an exam on the last day. So exam is quite important, but as long as you listen to the lecture, then it's not that bad. Sedimentation, flotation. I have course on flocculation and agglomeration level. Also, this part, the Professor Mugwadi, he covered some of them. Yeah, centrifugation. This is a really important subject, like this. This one probably you will see when you visit the dairy company. They use a lot.
Yes.
Yeah. So I'll give you one example of it. I love to drink milk, but not whole milk. Okay. My favorite is 1%. 1%, because 1% that a little bit of the cholesterol, but not a lot. So that's why I like 1%. That's my favorite. Also, you can make yogurt out of 4%, but skim is not easy to make. So I'm chemist. Also, I have some other minor major is it's more or less the biological area. So this one, there are several reservoirs. So you can take 1% or 4% during the centrifugation. So you will see a lot. You use this equipment when you visit the dairy company. This one is probably, I don't know whether you already knew about this process. Anyone knows about this? Flotation. This is really important part of the separation process. Currently, a lot of companies they are using this one, this technology.
Is there any specific industries that?
Well, I'm going to go a little bit detail. Yeah. I don't know whether you notice or not. This is all bubble. Right here is bubble. So this is the creation of bubbles. So you can separate that way. If a bubble, look at it, whether it's the oil affinity or well, I will have next time. Here, hydrophilic mineral, hydrophobic mineral, something like that. So if you are using bubbles, the surface is affinity to hydrophilic, hydrophobic, it depends on. Then this was the bubble. We create the bubble if you spin it. Yes, the bubble. Then the bubble catches only hydrophobic mineral and then fluorine. That's why you can separate it out. This is a quite interesting one. This technology is not that old. You know, frost, flotation process. Frost is the method of bubbles. Here you crush ores and mix with the water to form a slurry. Addition of reagent. I don't know whether you heard of xanthase. 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 Have you heard of it? Xanthase. It's a sodium salt. Sodium salt. So you have to add the xanthate and frost, which is pine oil. It depends what type of the material you want to eliminate. So aeration is quite important. So the frost flotation process came out. It's not really long time ago. Maybe about 10 years, something. But it has been quite popular at this time. It's more like the schematic of the material that we cover, making frost. Sometimes you use the compressed air to make a bubble. Advantage, almost all type of mineral can be separated by this process. Surface property can be controlled. an ultra flotation reagent. See, I gave you one the Zen state, and so that is only one the example. There are a bunch of others too. And disadvantage, this is correct, is quite expensive because the material that we have to use, it has to be compatible with the material you're going to filter out. So, last one is a quite important one too. It's dependent on operator. So operator is quite important, especially liquid filtration. The operator, she or he knows the principle of it, then probably the efficiency is rather high, but somehow the principle is not that strong, then it's trouble. That's why you are here, to learn the principle. So, during this presentation, I'm not going to go over some principles. However, the material that I don't know whether you already have it or not, the two-paper real old one, that has basic principle there too. So if you like to understand the liquid filtration, I strongly recommend to read those two papers that I gave you. The basic information is there. And then you're going to have my patent, this one. Yeah. I believe you have some.
Yeah,
huh?
the soft copy you have got.
Yeah. Yes. This is the media design. How you're gonna design the multi-layer media. The principle is there. The example is there too. So this is a quite important paper. I'm not gonna go over detail. I'm gonna go over a little bit later on. You know, when I teach, what I like to teach is, I like to teach the course you never heard of it. See, the course is established a long time ago, but there was no instructor to teach that course. For instance, flow through porous media. The course is the chemical engineering. Any school, they have flow through porous media there. But when I look at the history, no one wants to teach that. And so I just volunteered to teach it. So you have to know the mass transfer phenomena. Otherwise, you may not be able to understand the principle of it. The other thing, basic is so important. However, if you know a little bit, then you cannot apply it. If you like to apply basic principles, I'm going to give you some example later on. The basic fluid mechanics, the issue, if you like to apply those principles, then you have to understand basic one. Here, engineering field, important thing is you got to know stress. You have to know strain. Yeah? Stress, strain. Then you have to know mechanism. Yeah? So it's some balance equation. How is it? Momentum balance equation. Even though it's quite simple Poiseuille's equation, something like that. But you have to understand basic really well. Then you can apply to the real world. The one that I give you, the cordless media, same thing. The principle here is the same thing. All of them are basic fluid mechanics. However, like I told you, if you do not know really the principle of it, you may not be able to apply it. You don't know how to apply it. So important thing is somehow you got to know the basic as well as application part of it. Decanting, I believe you already know about this one. Hydrocyclone. This one looks like the two-dimensional, actually is rotating. Here, this is the schematic. And solid comes out, and liquid going over that, the vortex. This is one of the sedimentation. We actually use this one at the waste treatment and then water treatment. So they have some combination of hydrocyclone along with the sedimentation. Magnetic separation. Well, actually he covers some of them. Magnetic separation. Mining industry, they do use a lot. High gradient magnetic separation. So, example, the kaolin clay purification to remove iron oxide, then the magnetic separation is good. Wet drum magnetic separation. He show you the dust removal kind of video, but this one is a little bit different. They use magnetic separation, but principles stay the same. Okay, that one probably you may be able to see your book. The book you're gonna have it. I don't know whether you already have it or not. Email. Yeah. This one is there. So it's a magnetic separation. Here, this is the stainless steel filter media, and then magnetic is right over there. This technology is quite old one. This one I got it from the Journal of Sustainable Engineering, Volume 2, 2009. They have the rotating tube, and then oh my dear. No, that's it. Okay, good. Thank you. Yeah, positive electrode, negative electrode. So somehow you can separate out using the. This is not the magnetic. Rotating tube. It's electrode separation, not magnetic, I think. Yeah, that's electronic separation. So this one, they use a static electrode. Normally, if you use the applying some electric, then normally they use high voltage. So you can separate the any type of the solid material, separating like that. It's more like the classification. I'm not sure whether this one is commercially available or not. It's 2009. So this is corona charging. And separate the amount of the charging level of the on the surface of particles. Then you can separate that way. That's another one, electrostatic separation. See, I put the source down here. So if you really like to look at the in detail of it, then you can actually look at the electro-osmosis dewatering. See, if it is dewatering, it's really high purity. So the media you have to use is really fine. It's more like a membrane. Yeah. We're going to cover membrane later though, in detail, because membrane is booming. Yeah? It's really getting more popular than before. So here, I use media here, but actually this is not media. It has to be membrane. Membrane. This one is in your book. Okay, now the liquid separation mechanism. Decantation, centrifugation, extraction, membrane separation, distillation, he covered already, coalescing, settling, electrostatic separation. So when I was working for the Cummins engine company, I did only on coalescence, because the engine oil, sometimes you have a lot of cooling, the water is mixed with it. So you have to separate out. The other important area is the fuel. Fuel, sometimes you have a lot of water in it, so you have to separate out. That's why the coalescing is quite important factor. So if you work for industry, then the company, the value of company, there are two sections: intangible asset and tangible asset. What is the intangible asset? That's patent. Yeah, yeah. They call it proprietary information. so, so since I have more than 50 patents, that's company property. Company. Then you can work like like at the school. If you are 70, hey, go, 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 go quickly. But once you have the pattern, something like, hey, I'm going to go over this one. Oh, please stay, please stay. That's what happened. So right now, I'm more like I have my own company, even though. But anyway, you are not that old, but important thing is you have to have passion. You know what the passion is? You have to enjoy what you are doing. That's quite important. Without passion, you cannot achieve anything. So you have to have passion. I don't know whether you pay attention to the singing. If you get old, the voice must stay as probably 40 or 20s. But you pay attention to it, practice 30 minutes every day, and singing really nice song or something like that. Then what happens? Even though you're 80, still I can sing really loud. You'll see later on. I'm gonna see. Yeah, the principle is there, example is there, application is there. So decantation, we already discussed about it. Simplification, I'm going to discuss that one a little bit later, maybe an hour or so later. And extraction and membrane separation, I'm gonna cover that an hour. Membrane separation, and then distillation. Well, distillation. This one is really popular about 50 or 60 years back. You know what? The petroleum industry is booming. So petroleum, you have to go through distillation. Yeah? You know what? Without distillation, is diesel engine. That's the not. Well, they actually use a slight the distillation process, but not a lot. But gasoline that you buy for your car is distillation process. So the 50 years or 60 years ago, the distillation is quite popular, but not now. Distillation. And coalescence. This one is still popular, but I want to look at the contact angle carefully. Without knowing contact angle, you cannot do any research on coalescing. Coalescing is a quite important area. It doesn't have to be the automotive application. Food processing is the same thing. They use or not. Yeah, settling and electrostatic separation, we just covered slide earlier. One is kind of the summary of it: centrifugation, coalescence, and membrane separation, and solvent extract, thermal separation. This is the distillation. Electrocoalescence, this is quite interesting one, but the principles stay the same with combination of electric field and coalescing. Yeah, it's type of decantation is the density separation. It's a cyclone. The liquid cyclone, they do use some, but not a lot. But air, they use a lot. Here it is, the example of coalescing. I don't know, he already covered some surface filtration, and this one is the depth filtration. The coalescing occurs the other side of filter media. This one is surface filtration, more likely. So oil is floating from the water. So, but the design of the filter media looks simple, but it's not that simple. I told you earlier, every layer is not going to be one layer, single layer, several layers. Then you have to do contact angle test carefully. Then you can actually look at the multi-layer, design multi-layer. So designing multi-layer, the principle is right here. So use this one and contact angle, and you can actually design coalescing media. It may be PhD dissertation or not, but it's a quite interesting area. I got the schematics from Journal of Industrial Textile. Okay, this one, surface modification and membrane. This one came out 3 years ago. It's more like separating some the incoming pollutant, and then they pass through the membrane, and so you may be able to get the pure solvent permeate. So this is more likely highly sophisticated membrane material. So membrane, I'm going to cover the 1 hour of the membrane structure. So this one is a little bit early stage to talk about. Liquid extraction. The fuel oil, the electric solvent. If you add some solvent into the fuel, then you may be able to separate aromatic material with the treated fuel. I'm not really sure we're going to use this technology a lot when I work in the Cummins engine. We never use this one. But this is somewhere in the reference. This one already covered distillation. This is what you normally look at, making gasoline out of the raw petroleum oil. That one is a bit different process, only distillation. But principles stay the same as the previous one. Electrocoalescence, this is quite important one. It's recent technology. So two of the liquid particles, if you apply electric field, then it can coalesce, agglomerate, making big droplet, so that you can eliminate. Yeah, electrostatic coalescing. This one is really recent technology that I got 2 years back. So the oil phase drops, and then you can separate water phase using electron. I think that's the end of my presentation for separation. So I don't know.
3 p.m. sir.
Huh?
3 p.m. timing is.
CPM? Okay, what time?
Yes.
Do I need to?
Timing is right now 3 p.m. One hour is left. If you want to continue, then you continue. 1 hour is left right now.
Oh, okay. Okay, great. Then I'm going to go through the so-called the last session, which is the tutorial. Tutorial, I have bunch of material there. It's kind of a lot of equation there, but I'm not really sure whether it's a good material for in the afternoon. But probably in the morning might be better. but it's okay. Tutorial. Yeah, tutorial.